everyone. Welcome to this lecture series of optical instrumentation. My name is Sharad Gupta and this is lecture number 2, and in this lecture we will discuss about different theories of light. So, what are the theories of light? Since very long human beings were fascinated by light. Everybody wants to understand what is light. Life on earth is due to light, right. So, there were scientists from very thousands and hundreds of years, they are studying this the phenomena of light. Few theories were proposed to explain what is light. So, we will discuss few popular theories that are still being used to study different phenomena of light. Okay. So, these are the major theories: particle theory, wave theory, electromagnetic theory, and then in last quantum theory. Okay. So, let us start with particle theory. It is also known as corpuscular theory. It was proposed by Newton in 1660. Almost about 3.5 centuries back, 360 years back, Newton proposed a theory to explain what is light. It is also known as emission theory. Why? We will soon understand this. In this theory, Newton proposed that a luminous body continuously emits very small, very lightweight and very elastic particles in all the directions. Okay. So, this is an assumption that Newton gave, that any source of light, either sun or a simple tube light, a bulb or a torch, he proposed that every light source emits very tiny, very lightweight and very elastic particles in all the directions, right. And he called those particles corpuscles. What is the name that he gave to those particles? Corpuscles. That is why it is called corpuscular theory. And also he assumed that these particles are emitted from every light source. So, that is why it is also called emission theory or particle theory. Okay. These corpuscles are so small that they can readily travel through the intersections of substances, of materials. So, he assumed that these particles are so small that they can travel through material, the space that is between nucleus and electrons. So, it can travel through atom also. So, it can travel through matter with the velocity of light. So, it is so small. Also, they possess the property of reflection from a polished surface or transmission through a transparent medium. So, he also assumed that these particles are so elastic that they are reflected back from a polished surface, and they are so small that they can travel through matter if it is transparent, and they are so lightweight that their weight is almost negligible. So, in this theory Newton assumed various different things to explain different phenomena of light. Okay. So, how did he explain different phenomena? Passage through vacuum. So, particles can easily move or pass through vacuum. Okay, so this fundamental fact is automatically explained. Rectilinear propagation. Rectilinear propagation means light travels in a straight line. Even gravitation cannot change the path of light. So, as the mass of each corpuscle is negligibly small, the force of gravity acting on the corpuscles is too small to produce deviation from the straight line path, because the weight is negligible. So, even the force of gravitation does not work. The force that is acting is too small that it cannot deviate the light particles from their straight line path. Okay. This is how he explained rectilinear propagation, passes through vacuum. Dispersion. So, Newton assumed that particles of different colors, they are of different size. These corpuscles, they have different size for different colors, and the velocity is also different. Okay. Newton assumed that the corpuscles of different color are of different sizes and travel with different velocities in a dispersive medium. So, this is how Newton explained various facts about light. He tried to explain through this theory that he proposed, that any light source emit particles in all the directions. Now, this theory failed. Why? There are various reasons behind the failure of this theory. What were the reasons? Reasons for failure. This theory is based on number of ad hoc assumptions. He assumed most of the things that could not be proved. According to this theory, the velocity of light in a denser medium is more than a rarer medium. But from the fundamental facts, we know that the velocity of light in rarer medium is more. But according to this theory, it is in the denser medium in which the velocity of light is more. So, this is one of the reasons behind the failure of this theory. Also, Newton proposed that the pressure exerted by a normal incident light beam is equal to twice the energy density of the incident beam. But later it was measured that the pressure is not twice, it is equal. Experimentally, it is found that the pressure is equal to the energy density, not twice. Okay. So, this is second reason. If light of stream particles emitted from the source, the velocity of particles should increase with the temperature of the body. If any light source is emitting particles, then with the temperature the energy of particles must change. If the temperature of light source is more, then the energy of particles should be more, and if energy is more, the velocity should be more. So, if sun is emitting light ray and a tube light is emitting light ray, then the velocity of light from sun should be more than the velocity of light coming from a tube light or bulb. But it is found that the velocity of both the lights is exactly same in same medium. Okay. So, velocity of light does not depend on the temperature of the body, but if it is a particle, then it must depend. Okay. Another reason, if any source is emitting particles, then there should be certain decrement in the mass of that light source. For example, a light bulb is emitting light rays in all the directions for 24/7 for 1 year, there should be slight decrease in the mass of that bulb, but it is never observed. The mass of that tube light or bulb does not change at all. So, if light is a particle, there should be a slight decrement in the mass of that light source. So, this is one more reason behind the failure of this theory. Some of the very important facts that this theory could not explain were interference, diffraction, polarization, double refraction. Using this theory, Newton could not explain these fundamental facts of light that were observed by everyone. How diffraction is there, why polarization is there, why interference is there. Okay. So, due to this, some scientists agreed with this theory, but most of the scientists, they did not agree with this theory, particle theory of Newton. Okay. After this came the wave theory. It was proposed by Chistian Huygens in 1679. After around 19-20 years, another scientist, Chistian Huygens, he proposed a different theory, and he proposed that light is a wave. Light is a form of energy that travels in the form of wave through any medium. So, what did he propose? A luminous body is a source of disturbance, it is a source of energy, that is emitting energy, or we can say disturbance in all the directions. In a hypothetical medium called ether, he also assumed that this whole universe is filled with the hypothetical medium ether, because light rays or a wave needs certain medium to travel. Okay. So, he assumed that this whole universe is filled with a hypothetical medium ether. The hypothetical medium ether pervades all space. Okay. The disturbance from the source is propagated in the form of waves through the space, and energy is distributed equally in all the directions. Okay. So, this disturbance travels in form of waves in all the directions. Okay. Huygens assumed that these waves are mechanical in nature and longitudinal in characters. So, he assumed that these waves are longitudinal. That is why a medium is needed, like sound waves, they need a medium. He assumed that when an ether particle is disturbed, it acts as a fresh source of energy, fresh source of disturbance, and emits secondary wavelets in all the directions. So, this is the theory that he proposed. With this theory, he explained a lot of facts. With this theory, he explained reflection, refraction, dispersion, double refraction, but there are few fundamental facts that he could not explain, like rectilinear propagation, polarization, and diffraction. Few fundamental facts he could not explain. But so, when he could not explain these facts, few scientists were following the particle theory of Newton, and few scientists were following the wave theory of Huygens. But after around 1.5 century, Fresnel and another scientist, he explained rectilinear propagation and diffraction. And after few more years, Fresnel and Young independently proved that light waves are transverse waves. They are not longitudinal. They proved that these waves are not longitudinal, these waves are transverse waves. Okay, what are transverse waves? In transverse wave, the particles of medium vibrate perpendicular to the propagation of the wave. The medium particles vibrate in the perpendicular direction with respect to the direction of the propagation of the wave, and in longitudinal wave medium particles vibrate along the ray of propagation of ray. Okay. So, if a transverse wave is moving in this direction, then how medium particles will vibrate? Like this. Such ray is called transverse, such wave is called transverse wave. So, they explained that light is a transverse wave. Okay. So, this further explained, this was further helpful in explaining polarization. This was further helpful in explaining the fact of polarization that was not explained earlier by Huygens. Okay. So, after around 1.5 century, almost all the scientists, they agreed that light is not a particle, it is a wave, and wave theory became much more popular than particle theory. Okay. After this came the electromagnetic theory. Electromagnetic theory. So, it was introduced by Maxwell in 1864 after around 200 years. When first particle theory was proposed by Newton, Maxwell gave electromagnetic theory. Now, what is electromagnetic theory? According to electromagnetic theory, light waves are of same character as electromagnetic waves. Light waves have same characters that electromagnetic wave have. What are electromagnetic waves? Electromagnetic waves are created by vibrating electric and magnetic field in any space. Okay. Electromagnetic waves, how do they propagate through space? Through varying electric and magnetic field. Waves are propagated through space by varying electric and magnetic field whose direction is mutually perpendicular to each other. So, if the vibration of electric field vector is like this, then magnetic field vector will vibrate like this. Okay. So, the vibration is mutually perpendicular to each other, and how electromagnetic waves propagate through space? Through this vibration, as well as perpendicular to the direction of propagation. So, if magnetic field is vibrating like this, electric field is vibrating like this, then what is the direction of propagation? Direction of propagation is this. Light ray will come either out of this screen or it will go inside this screen. So, this is the direction of propagation of electromagnetic wave. Okay. So, this theory also gains support by the fact that the velocity of light waves and the velocity of electromagnetic waves is same. Okay. Also, this theory explains all the phenomena of geometric optics as well as the phenomena interference, diffraction, polarization. Most of the phenomena were explained by this theory. So, in a way, this theory subsumed wave theory of light. So, it is also a kind of wave theory and it adds something. So, it overall subsumed the wave theory of light. Okay. So, this is electromagnetic wave. You can see the light is wave is propagating in this direction. This is electric field vector vibrating perpendicular to the motion of the light ray, and this is magnetic field vector vibrating perpendicular to the electric field vector and to the direction of propagation of light. Okay. We will discuss this in more detail in next lecture. Lastly came the quantum theory of light. Quantum theory of light and duality, dual nature of light. Later on, few phenomena discovered concerning the interaction of light with matter. After few years, there were certain phenomena that were discovered, and those phenomena were about the interaction of light with matter. Such as photoelectric and Compton effect. Photoelectric effect and Compton effect. So, how do we study photoelectric effect? We consider light as a packet, and when light rays or a packet strikes an electron, it gets excited, it jumps to a higher energy level, or it comes out of the atom, right. So, this is photoelectric effect. These effects could not be explained by wave theory or electromagnetic theory. Photoelectric effect and Compton effects, these effects could not be explained by these two theories. So, after around 200 years, everybody considered and agreed that light is a wave. Then again a new question came into picture, that is actually light is a wave, because these phenomena were explained, can be explained by particle theory, but they could not be explained by wave theory. So, the question of nature of light was reopened. These phenomena were explained by particle theory of light, developed in its modern form by Planck and Einstein. So, what Planck and Einstein did? In 1900, Planck proved that emission and absorption of electromagnetic radiation can occur only in form of discrete packets, and he gave it a name quanta. He said that light rays or electromagnetic rays can only be absorbed or emitted in form of packets only, discrete packets. And he also gave an equation, through that we can calculate the energy of that packet, with the energy of a packet being directly proportional to the frequency of radiation. So, energy is proportional to the frequency of light. So, what is the energy? H into F. Energy of packet is H into F. H is Planck's constant, we all know, and F is frequency of light. After 5 years, Einstein proposed that electromagnetic radiation is itself granular, consisting of quanta, each with energy h nu. Okay. So, they gave a name quanta, and they considered that electromagnetic waves are granular. So, wave is granular, there are grains, small packets, small particles. Although this proposal explains the phenomena related to interaction of light with matter, but again it was inadequate and it cannot explain other phenomena that were explained by considering light as a wave. For explanation of some phenomena that are related to the wave character of light, such as interference and diffraction. So, for a unified explanation, what they did? They considered that light has a dual nature. Sometimes it has a nature of a particle, and another time it has a nature of a wave. For unified explanation of all the phenomena related to the particle and wave nature of light, the quantum theory was introduced by de Broglie, Schrödinger and Heisenberg. So, later on these three scientists, they proposed another theory that is called quantum theory. So, quantum theory was not actually proposed by Einstein and Planck, it is based on their research, but it was proposed by Broglie, de Broglie, Schrödinger and Heisenberg. So, this theory attributes to the light the characteristics of both particles and waves. It considers that light has the properties of both particles and wave. It is a combination of both particle and wave theory of light. So, that is why it is called dual nature of light. So, what is current consideration? Current scientific theory holds that all elementary particles exhibit a wave nature and vice versa. All elementary particles, very small particles, electron, photon, proton, every elementary particle, all small particles, they have wave nature. So, sometimes they can act as wave and another times they act as particles. Okay. So, this is dual nature of light, duality of light. So, this was all about theories of light, particle theory, wave theory, electromagnetic theory and quantum theory. Thank you.